There is a rock sitting on the surface of Mars right now, tonight, sealed inside a metal tube about the size of a piece of chalk. A robot the size of a car drilled it out of the ground in the summer of 2024, in an ancient dried-up riverbed, and the rock has small dark markings scattered through it. The people who found them call them poppy seeds and leopard spots. On Earth, markings like that, in rock like that, would be a textbook signature of microbial life. After more than a year of careful review, the official position became that the sample contains what they carefully call a potential biosignature. Nobody is saying life, not yet. They are extremely careful with the word potential. But the tube is still there. It is sitting on the surface of a planet that went quiet roughly 3.5 billion years ago, waiting for us to come and get it. And the earliest we might bring it home is somewhere in the late 2030s. So for now, all we have is the photograph and a question we do not yet know how to close. Tonight we are going to talk about that rock, but not only about that rock, because Mars is not the only dead world. It may not even be a rare one. What we are actually going to sit with tonight is a question that does not get asked very often, because it makes people uncomfortable. Not are we alone? A different one. When we look up and wonder whether anyone is out there, we assume the interesting part is whether life ever starts. But the more we learn about what it actually takes to keep a world alive, the more it looks like the real story is not about life starting. It is about life lasting, and about whether, even if it is out there right now, on some world circling some other star, we could ever, in any sense that matters, reach it. This isn't a horror story, it's physics. And physics, when you look at it clearly and carefully, is more clarifying than frightening. There is a calm on the far side of understanding this that you do not get from looking away from it. So we are going to look at it directly. By the end of tonight, you are going to see the night sky a little differently. Not as a place that is empty, and not as a place that is crowded with company we simply have not met yet. As something stranger than either, as a kind of archive. A vast collection of worlds scattered across an unthinkable amount of space and an even more unthinkable amount of time, where the lights came on and ran for a while and in most cases went out again long before we ever looked. Worlds with the light still on and nobody home. And by the end, you are going to understand why the last living world our species may ever be able to reach might not be out there among the stars at all. It might be the one you are standing on. If that is the kind of thing you find yourself sitting with late at night, the real picture rather than the comfortable one, take a second to like the video or subscribe. It genuinely helps this channel reach more people who actually want to think about this honestly, the way you are willing to right now, instead of being sold a simpler story. That is all. Now let's get into it. Here is where most people go wrong the moment they start thinking about life in the universe. They imagine two doors. Behind door one, the cosmos is teeming with company. Life is everywhere, civilizations are common, and we simply have not run into anyone yet because space is big, and we have not looked hard enough. Behind door two, the cosmos is empty. Life is a fluke, a one-in-a-universe accident, and we are alone here, and that is simply how it is. And almost every argument you have ever heard about aliens is really just people fighting about which of those two doors we are behind. Are they out there, or are they not? There is a third door, and the third door is the one the evidence keeps quietly pointing at, and it is stranger than either of the other two, because it does not fit the shape of the argument people are used to having. The third door says this: the universe is not empty, but it is not full of company either, at least not company you could ever talk to. It is full of worlds where the conditions for life arrived and then left. Worlds where life may well have started and then stopped. Worlds that had their window, their long warm afternoon of being habitable, and then the window closed the way it has already closed on 2 of the 3 rocky planets in our own solar system. The universe on this third door is not a crowded city, and it is not an empty desert. It is something more like a graveyard with the lights left on. And that changes the question completely. The question was never really, is anyone out there? The question is when. When did each of those worlds come alive? When did it go quiet? And are any of them, anywhere, doing right now what the Earth is doing right now, at the same moment, close enough that it would ever matter. I want to give you a single question to carry the whole way up. It is going to be our through line, the thread we follow from the rock in the tube all the way out to the edge of what we can see. After each world we look at, I want you to ask it with me, is anyone home? That is the first half. And there is a second half that I am going to ask you to hold in your back pocket, because we do not get to it until the very end, and it is the harder one. Even if the answer is yes, even if somewhere out there a world is alive right now, could we ever actually reach it? Hold both halves. Is anyone home, and could we ever get there? Because the answers are going to shift as we go, and by the time we are done, both of them are going to land somewhere you are not expecting. If you want to know what one of those quiet worlds looks like up close, we do not have to travel far at all. We already have one. It is the planet next door. So let's start there. Let's start with Mars. Before we walk up to Mars, let's get the scale of the search straight, because the numbers are the first surprise. As of the start of 2026, the official count of confirmed worlds beyond our own solar system stood at 6,087. That is the number of planets we have actually detected, orbiting other stars, and logged in the register where confirmed discoveries go. Let me anchor that against something you can hold. There are about 195 sovereign countries on Earth. We have already found more than 30 times as many worlds beyond our solar system as there are countries on this one, and those are only the ones we have managed to catch. The real number, the estimated number, is not in the thousands. There are roughly 200 billion stars in our galaxy alone, and the working assumption, built on years of data, is that nearly every one of them has at least one planet. Some have many. Do that arithmetic, and you land somewhere in the hundreds of billions of planets, just in the Milky Way. And of those, the number sitting in what astronomers call the habitable zone, the band around a star where liquid water could in principle exist on the surface, runs into the tens of billions. Tens of billions of possibly habitable worlds in one galaxy. So why is it so quiet? The first thing to understand is that habitable zone is a genuinely misleading phrase, and a lot of the silence hides inside that phrase. Habitable zone only means liquid water could exist there in principle, given some friendly assumptions. It does not mean water is there. It does not mean water ever was there. It does not mean the planet has an atmosphere that could hold water, or a temperature currently in the right range, or anything at all beyond one fact, that the orbit sits at roughly the right distance from the star. So when you hear that there might be tens of billions of habitable zone planets out there, what is actually being said is that there are tens of billions of orbital slots where the conditions are not immediately ruled out, and the conditions can still be ruled out by 1,000 other things, and very often are. Out of the 6,000 plus worlds we have actually confirmed, most are nothing like Earth. Scorched gas giants hugging their stars, rocky worlds too big and too hot, planets with one face locked toward their sun forever, baked on one side and frozen on the other, planets with the air stripped off. When you go through the whole catalogue and ask how many are roughly Earth-sized, in roughly the right orbit, around a roughly stable star, the number that survive is in the low dozens. So part of the silence is simply that most of these worlds were never going to be alive in the first place. They do not have the chemistry, the temperature, the air, the time. They are stones in space. But that is only part of it, because the strange thing, the thing that is genuinely hard to explain, is not the worlds that never could have been alive. It is the worlds that maybe could have been. The Earth-like candidates are out there in real numbers, even by the most careful counts, and out of all of those, we have picked up nothing. No signal, no radio call, no chemical fingerprint we can point to and say, that is life. That is the silence that is hard to sit with. Not the silence of the dead rock, the silence of the worlds that by any decent statistical argument should have had something on them. There is an image I keep coming back to when I sit with this, and I want to plant it now, because we are going to return to it more than once tonight. The universe, at least the part we can see, is not quiet because nobody was ever in it. It is quiet the way an old library is quiet. You walk in at night and the lights are off, But the building is still there, the shelves are still there, the books are still there. Every spine you pull down has a real author behind it, real ink, real pages. The library was not built empty, somebody filled it, but it has been a long time. The writers are gone, the readers are gone, the lamps overhead have burned out, one by one, and nobody replaced them. The building has gone quiet, the books are still there, the voices are not. That is the third door. That is the universe we are actually going to walk through tonight. And the first dark room in that library, the one closest to where we are standing, the one we can actually walk into and run our hands along the shelves, is Mars. Mars is the easiest dead world to talk about because we can see it. On the right night you can step outside, find the small steady reddish light hanging in the sky, and there it is, the fourth planet from the Sun, the one next door, the one you do not have to imagine, because it is actually there. For most of human history it was just a wandering red light and a name for a god of war. It became a place in the late 1800s when telescopes got good enough to show polar caps that grew and shrank with the seasons, and dark patches that some astronomers talked themselves into believing were vegetation, and long straight lines that one astronomer became convinced were canals, dug by a dying civilization to move the last of its water from the poles to the equator. None of that turned out to be true. The lines were the eye trying to make sense of a blurry image. The dark patches were dust and stone. There were no canals. But here is the thing. The idea of Mars as a dying world turned out to be closer to right than anyone realized. They had the story, they just had the details wrong. The Mars we have today is by any reasonable definition dead. The surface averages about 63 degrees below 0 Celsius. That is roughly the coldest temperature ever recorded in Antarctica, except that on Mars it is not the extreme, it is the average. The air is so thin that liquid water on the surface would boil and freeze almost in the same instant because the pressure is too low to keep water liquid at all. Stand there in a perfect suit and the cold would soak up through the soles of your boots within minutes. The sky overhead would be a pale butterscotch colour, not blue, because there is not enough air to scatter the light the way ours does. The sun would look smaller and dimmer. The horizon would feel close, because Mars is a smaller world and the ground curves away faster. It would feel like a place that something used to live in, and that feeling, it turns out, is exactly right. Here is what happened to it. Mars used to have a magnetic field, a real one, a planet-wide one, generated by a core of molten metal spinning at the center of the world, the same way the Earth's core spins now. And that magnetic field was a shield. It deflected the solar wind, the constant stream of charged particles the sun throws off in every direction. And that shield meant Mars could hold on to its air, and the air meant water on the surface could stay water, and a sky thick enough to feel like a sky. Then the shield went down. The best estimate is that Mars's global magnetic field collapsed roughly 3.9 billion years ago. The core cooled, the churning slowed, the dynamo stopped, and the shield simply faded away. And after that, the atmosphere began to bleed. Not in one dramatic event. Over hundreds of millions of years, the solar wind picked at the top of the air, knocking the lighter molecules off into space, one at a time, so slowly that if you had been standing on the surface watching, you would not have noticed anything change from one century to the next. But the account was running in the red. More air was leaving than was being replaced, and eventually the account ran dry. Today the surface pressure on Mars is less than 1% of ours. To find air that thin on Earth, you would have to climb to about 30 kilometers up, 3 times higher than a passenger jet flies. That is the air Mars now has at ground level. But there was a window, a long one, and inside that window, things happened. There is a rover called Curiosity that landed in a crater called Gale in 2012, and it has spent more than a decade slowly driving up the slopes of a mountain in the middle of that crater, reading the rock layer by layer like pages. Gale crater was a lake, we know that now. The layered mudstones, the river-rounded pebbles, the salts, the clays that only form in standing water, all of it tells the same story. Around 3.8 billion years ago, this part of Mars was full of liquid water, a deep lake fed by rivers that stayed for a very long time. The mineral evidence suggests it persisted on and off for something like 700 million years, with the last clearly habitable conditions winking out somewhere around 3 billion years ago. And 700 million years is a length of time that is genuinely hard to hold in your head. Complex life on Earth, anything you would recognize as an animal, has only existed for about 600 million years. So Mars had a warm, wet, habitable surface for longer than the entire history of complex animal life on Earth so far. And in that same era, on the planet next door, Earth had already caught. The earliest solid evidence of microbial life here shows up in rocks around 3.5 billion years old, with some debated hints going back further, which means the two planets were running the same experiment at the same time. They had liquid water at the same time. They had atmospheres at the same time. One of them, we know for certain, grew life. The other one had every ingredient to do the same thing. And then, around 3 billion years ago, the conditions on Mars stopped being friendly and the window closed. Which brings us back to the rock, because there is a second rover called Perseverance that landed in a different old crater, Jezero, another place that used to be a lake, where you can still see the fossil fan of an ancient river delta from orbit. Perseverance was sent there for one reason above all others, to look for signs of past life. And in the summer of 2024 it drilled into a rock, and the sample it pulled out had those dark nodules scattered through it, the poppy seeds and leopard spots, in patterns and in minerals that, on Earth, are exactly the kind of things certain microbes leave behind when they pull energy out of sediment. The people who published the analysis were painfully careful. They did not say life, they said potential biosignature. They listed every other explanation, every way that chemistry with no biology in it could, in principle, produce the same marks. They found the first thing you would point to as evidence of life, and then they told you honestly all the ways it might be nothing. And that sample is still sitting there, on the surface of Mars, in its sealed tube, waiting for a mission to go and bring it home. A mission whose schedule has stretched out into the late 2030s and possibly beyond. The most consequential rock our species has ever laid eyes on is going to sit on another planet in a metal cylinder in the wind for at least another decade while we figure out how to reach it. If you have ever moved into a house someone else used to live in and gone up into the attic, you know a particular feeling. There is a box up there. It has photographs in it. Real photographs, real faces, in clothes you do not recognize, in rooms you have never seen, and you realize you are holding pictures of people who walked through your hallway and ate in your kitchen generations before you ever arrived. They are not your family, they are just people. And the fact that they were here, doing ordinary things in the same physical space you now live in, is hard to fully absorb the first time it lands. Mars is that attic. You climb up expecting dust and emptiness, and instead you find a photo album. The pictures are real. They are of someone you never met, and the camera that took them stopped working a very long time ago. So let's ask our question. For the first time, standing in that dark room, with the box of photos open in our hands, is anyone home? And the honest answer, the one the scientists themselves are careful to give, is we do not know. There may be a fingerprint in that rock. We cannot yet reach it to be sure. Mars's porch light is still on, in the sense that the sun still rises on it every morning and lights up the empty rooms. We have been ringing the doorbell for 60 years. Mostly, the house is quiet. The wind blows red dust against the door. Nobody answers. And Mars is the easy one, the obvious one, the one that is hard to think about only because it is our actual twin. The world we usually skip, the one we file under too hot and stop thinking about, is the planet on the other side of us. And it may be the more important story. Let's talk about Venus. We do not think about Venus the way we think about Mars. Mars gets the rovers, the magazine covers, the colony fantasies, the square-jawed person in a spacesuit. Venus gets about a week in school. It is the one with the runaway greenhouse, the one that is too hot, the cautionary tale, the example the teacher uses for what happens when a planet gets too much carbon dioxide and then you move on. And that telling is wrong, or at least it leaves out the most important part. Venus, on paper, is Earth. almost exactly Earth. It has nearly the same diameter, the same mass, the same density. It formed at the same time, out of the same material, in the same inner solar system. It is our sister world by every standard astronomers used to mean by that phrase. If you handed a stranger the basic specifications of two planets, one labelled Earth and one labelled Venus, and asked them which one supports life, they would have no way to tell. And here is the part one genuinely think people should stop and sit with. Venus may have been habitable, with liquid water oceans on its surface, for as long as 2 to 3 billion years. That is not a wild guess. That is the conclusion of detailed climate models run forward in time under reasonable assumptions, which find that Venus could have held a stable, temperate climate with real oceans for 2 to 3 billion years before it tipped into what it is now. Let me anchor that. Complex life on Earth, anything more than single cells, has existed for about 600 million years. Venus, on this timeline, had liquid oceans on its surface for something like 5 times longer than complex life has existed on Earth. There was, on the surface of that planet, an environment that by any reasonable definition was habitable, for a stretch of time that dwarfs the entire run of animals on our own world. Whether anything ever lived in those oceans is a different question, and it is one we may never be able to answer, but the oceans were there. For billions of years, Venus was not the cautionary tale. Venus was a second Earth. Then, somewhere around 700 million years ago, it flipped. The exact trigger is debated. It may have been a vast pulse of volcanic activity that repaved the whole planet and flooded the atmosphere with carbon dioxide. It may have been the slow, steady brightening of the sun, which grows about 10% brighter every billion years, finally pushing Venus past a line. It may have been more than one of those things together, but whatever lit the fuse, the climate went into a feedback loop that could not stop. Water vapor is itself a powerful greenhouse gas, so a little warming put more water vapor in the air, which trapped more heat, which warmed the surface more, which put more water vapor in the air. The oceans began to evaporate. The more they evaporated, the hotter it got. The hotter it got, the more they evaporated. That runaway did not stop until the oceans of an entire planet were gone, lifted into the sky, and then broken apart by sunlight, and lost, piece by piece, to space. This is the pot on the stove. You put a pot of water on to boil, and you mean to come back when it is ready, and then you get a phone call, and someone comes to the door, and you forget. And when you finally remember and walk back into the kitchen, the water is gone, and the bottom of the pot is glowing. That is Venus. For a long time, the pot was fine, the water simmered. You could still see the surface of it, still see the bottom. Then the level dropped, then the pot was dry, then the pot was glowing. Venus has been a glowing pot for 700 million years, and the burner will not turn off. What is left is one of the most hostile places in the solar system. The surface averages about 460 degrees Celsius, hot enough to melt lead. The air pressure at the surface is about 92 times what you feel here, the pressure you would meet almost a kilometre down in the ocean. The sky is a thick, sulphurous, poisonous gloom, with clouds of sulfuric acid that rain down and then evaporate again before the drops ever reach the ground, because the lower air is too hot for them to survive the fall. A few Soviet landers touched down there in the 1970s and early 80s, and lasted on average less than 2 hours before the heat and pressure killed them. That is Venus now, a place where lead would puddle on the ground, under an atmosphere that would crush you and cook you and corrode you all at once. And here is the part that, for me, makes Venus harder to think about than Mars. The oceans did not vanish without a trace. They left a ghost. If you measure the air of Venus carefully, and you look at the ratio between ordinary hydrogen and a heavier version of hydrogen called deuterium, you find something that makes no sense, unless Venus once had far more water than it does now. On Earth, deuterium is rare, about 1 part in 6,000 of the hydrogen in our oceans. On Venus, the ratio of deuterium to ordinary hydrogen is roughly 150 times higher than it is here, and there is only one good explanation for that. Light hydrogen escapes to space more easily than heavy hydrogen, because lighter things move faster and get knocked off into space first. So if you take a planet that started with both kinds mixed in its oceans, and you boil those oceans into the sky, and you let sunlight work on that water vapor for a few billion years, the light hydrogen streams away faster, and the heavy deuterium lingers, and the ratio between them slowly climbs. When we measure that ratio on Venus today, we are measuring the chemical fingerprint of an ocean that boiled into space billions of years ago. The water is gone. The trace of the water is not gone. There is a kind of quiet grief in that detail, once you let it land. We do not usually think of planets as having ghosts, but Venus has one. It is chemical, it is measurable, it is still there, hanging in the air, the shape of an absence, an entire ocean, reduced to a number on a spectrometer. And here is why that ghost matters for everything else tonight. We could read a signature like that from across the galaxy. If Venus were orbiting another star, 60 light-years away, and we had the right instrument pointed at it, we could measure that deuterium ratio in its atmosphere and say, with real confidence, this planet used to have a great deal of water and now does not. We could read the obituary from across the dark without ever going there. And there may be worlds out there right now for which we have already done exactly that and simply not recognized what we were looking at. The first time we read a Venus-like ghost on a distant world, we will not be making a discovery. We will be confirming something the universe has been quietly recording the whole time, the fingerprint of an ocean that is no longer there. So let's ask our question again. Standing on the second dead world in our own backyard, is anyone home? And on Venus, the answer is even harder than on Mars, because on Venus the record itself has been erased. Whatever might have lived in those oceans, if anything did, was baked and crushed and chemically scrubbed away when the surface became what it is now. There are no fossils to find, there is no rock to drill that remembers. Mars keeps its secrets in a sealed tube we cannot yet reach. Venus burned its diary. Venus's porch light has been on for 4 billion years, and the house behind it burned to the ground. So now we have two dead worlds in our own neighborhood. Mars, killed by a cooling core and a lost atmosphere. Venus, killed by a runaway fire that boiled an ocean into the sky. Different deaths, same result. Two planets, the same age, the same materials, the same starting hand, and one of them ended in the cold, and one of them ended in the fire, with Earth sitting in between. Which raises a question that ought to make anyone a little uncomfortable. If two of the three rocky planets that started inside our Sun's habitable zone have already lost their habitability by two completely different mechanisms, how stable is any habitable zone anywhere? What does that tell us about the third one? That is where we have to look next. Because it turns out the habitable zone itself is not a place you can plant a flag in and stay. It moves. When people first hear about the habitable zone, the picture that lands in their head is a kind of permanent neighborhood, a ring around a star, and inside the ring it is just right, and outside the ring it is not, and the planets inside are the good ones and the planets outside are too hot or too cold, and Earth is inside the ring, and that is the end of the story. Almost none of that is right. The habitable zone is real. It is very specifically the range of orbital distances at which liquid water could exist on a planet's surface, given some basic assumptions. But it moves. It moves because stars change. Stars look steady to us only because our lives are short, and stars change slowly. Over billions of years, every star brightens. A star like our Sun fuses hydrogen into helium in its core, and as it does, the core slowly grows denser and hotter, and the star puts out more energy. Year by year the increase is invisible. Over billions of years it adds up. Our Sun has brightened by roughly 30% since the Earth formed. That is not a small adjustment. That is the difference between a comfortable room and a fever. And it is still brightening at a rate of about 10% every billion years. And as the star brightens, the whole habitable zone, the whole band where water can be liquid, creeps outward, away from the star. The inner edge, the line inside which water simply boils away, moves outward year by year, slowly, relentlessly. There is a way to feel this that helped me more than any diagram ever did. I learnt a little piano once, just enough to make the easy songs sound right, and one of the first things you learn is that the keys you can reach with one hand are limited. You have an octave, a handful of white keys and black keys sitting under your fingers when your hand is resting on the keyboard. If you want notes outside that octave, you have to move your hand. The habitable zone is the playable octave for liquid water. Inside that range, the notes work. Water stays liquid. Life has somewhere to stand. Outside it, the notes are too high or too low, too hot or too cold, and the music falls apart. But here is the thing. The piano is not standing still. Someone is slowly pushing it across the room. The playable octave is sliding outward over time, and the keys you used to be able to reach keep falling off the edge of the bench. And this is not a metaphor floating free of the facts. It is the facts. Mars's keys fell off the bench around 3.5 billion years ago, when the brightening sun and Mars's own dying core left it out in the cold. Venus's keys fell off around 700 million years ago, when the inner edge of the zone swept past it and the oceans boiled. Earth's keys are sitting, right now, roughly in the middle of the playable octave. Comfortable, in tune, for now. But the piano keeps moving, and the keys keep sliding toward the edge. Let me put a number on where that leaves us, because it is more specific than most people expect. In about 1 billion years, give or take, the inner edge of the sun's habitable zone will reach the Earth's orbit. That does not mean the planet ends that day. It means the slow machinery starts. As the sun brightens, the surface warms, more water evaporates into the upper air. Sunlight breaks that water apart, the hydrogen escapes to space, the oceans begin, molecule by molecule, to thin. The same process that emptied Venus, playing out here on a longer clock. Most careful models converge on a window of somewhere between 1 and 1.5 billion years from now, before complex life on Earth becomes untenable. Not the planet gone, the planet with forests and oceans and animals and weather gone. Microbes might hang on longer in the deep places, but the world you would recognize, the living world, has roughly 1 billion good years left. We are, demonstrably, past the middle of Earth's habitable life. Not by a little. Earth has been habitable for about 4 billion years and has maybe one more to go. The largest part of this planet's living history is behind it, not ahead. That is not a doomsday claim, and it is not next week, and it should not change a single decision anyone makes about their actual life. But it is true, and it reframes what Earth is. Earth is not in its morning. Earth is in its late afternoon. The light is still warm. The evening has not started, but it will. And here is the part of the moving octave that reaches all the way out to those tens of billions of distant worlds and quietly poisons the whole catalogue. When we find a planet sitting in the habitable zone of some far-off star, and we write it down and say liquid water could exist there, we are taking a snapshot. We are seeing the conditions at one moment, but the habitable zone of that star has been sliding the whole time, just like ours, and it will keep sliding. A planet that looks perfectly placed today might have been a frozen ball 1 billion years ago, and might be a scorched rock 1 billion years from now. A planet that is a frozen wasteland today might have had its golden age 1 billion years back, when the star was dimmer and the zone sat further in, and we have simply arrived too late to see it. The galaxy is full of planets in the wrong place at the wrong time, full of worlds that had their best era long before we looked, and worlds that will not reach their best era for 1 billion years yet. The number that happen to be in their living moment right now, at the same time we are, is a small slice of the total. We are one of them. The window is open here. The window is closed, or not yet open, on most of the rest. Habitable zone, it turns out, has a time problem buried inside it that we almost always ignore. A planet is in the zone now. That does not mean it always was. That does not mean it always will be. That does not mean anything ever lived there at all. And that is around a calm, well-behaved star like ours, putting out a steady amount of light over a long, patient life. The sun is, by the standards of the galaxy, an unusually easy neighbour. Most stars are not like the sun. Most stars are smaller, redder, dimmer, and far less patient with the worlds that orbit them. And most of the habitable zone planets we have found do not orbit stars like the sun. They orbit those other stars, the violent ones. That is where we have to look next. When most people picture a star with planets around it, they picture our sun, a yellowish, steady, even-tempered star hanging at the center of things, throwing off a comfortable amount of light, doing its job without any drama. That is the star you imagine when you imagine alien sunlight on an alien beach. That is not what most stars look like. Roughly 3 out of every 4 stars in the Milky Way are a kind called a red dwarf. They are small, much smaller than the Sun, ranging from about half its mass down to less than a tenth. They are cooler and dimmer, and they burn their fuel so slowly that the smallest of them are expected to last for trillions of years, far longer than the entire current age of the universe. And because they are the most common star by a wide margin, 3 out of every 4 habitable zones being studied right now are around red dwarfs. 3 out of every 4 times you hear the phrase Earth-sized planet in the habitable zone, it is a planet orbiting a red dwarf. So when we talk about how many habitable worlds might be out there, we are mostly by default talking about red dwarfs. The math just works out that way, and that matters because red dwarfs are not gentle, not even close. Here is the trap. On paper, a red dwarf looks friendly to life. It lasts almost forever, which sounds like plenty of time for life to get going and stick around. It puts out a steady amount of energy over that immense lifespan, but there is a catch, and it is a brutal one. Because a red dwarf is so dim, the habitable zone, the band where a planet would get Earth-like warmth, sits very close to the star, much closer than Mercury sits to our Sun, and small stars especially are magnetically furious. They churn and flare in a way our Sun almost never does. Red dwarfs throw off flares that can be, in the worst cases, thousands of times more powerful than the strongest flare our Sun has ever produced, and they do it constantly. Take the TRAPPIST-1 system, 40 light-years away, one of the most studied red dwarf systems we have. It is a headline system, and for good reason. It has 7 Earth-sized planets, several of them sitting in the conventional habitable zone of their star. On paper, it is exactly the kind of place you would want to look for life. 7 rocky worlds, more than one of which could in principle hold liquid water, all around a single nearby star. And then we watched it. Recent observations measured the flare activity of that star over a sustained stretch and found that it produces roughly 6 flares a day. 6 a day, every day. That is more than 2,000 flares a year, every year, for billions of years. And the planets in the habitable zone, which orbit closer to that star than Mercury orbits ours, take those flares full in the face without any of the buffer that comes from being far away. They are sitting right next to the speaker, and the volume is at maximum, and it has been at maximum since the system formed, and it will stay at maximum for the rest of the star's life, which is to say for trillions of years. What does that do to a world? Laboratory studies have tried to find out, exposing even the most radiation-hardy microbes we know of to the kind of dose those planets would actually receive, and the general picture is grim. Flares of that size, at that frequency, are enough to sterilize almost anything living on an exposed surface. Anything in shallow water, in topsoil, out under the open sky, gets cooked. Some life might survive deep underground or under the ice of a buried ocean, but the kind of habitable surface that complex life on Earth depends on, the open sky, the running water, the green things turning sunlight into food, is very hard to keep on a world that gets hit with that kind of radiation every few hours, forever. And there is a second problem with red dwarf worlds, on top of the flares. Because the habitable zone is so close to the star, the gravity is strong enough over time to lock the planet's rotation to its orbit. The same face always points at the star. One hemisphere lives in permanent daylight, baking under a red sun that never moves in the sky. The other hemisphere lives in permanent night, cold enough that the air itself might freeze and fall as snow. Between them runs a thin ring of perpetual twilight, the only strip where the temperature might be reasonable for liquid water, a narrow band of maybe habitability on a world that is otherwise half oven and half freezer. Whether that strip can actually hold a stable, living environment depends on details of atmosphere and circulation that we mostly do not yet know. It might work, with the right air and the right luck. Or the atmosphere might slowly drift to the night side and freeze out there, leaving one hemisphere with a frozen sky and the other with no air at all. So when we count up the tens of billions of habitable zone planets in the galaxy, we have to be honest about what that number is really made of. Most of them orbit red dwarfs. Most of them sit closer to their star than Mercury. Most of them are getting hit with flares, many times more powerful than anything our sun produces, several times a day, for the entire life of the star. Many of them are tidally locked, half burning and half frozen. The phrase habitable zone, applied to those worlds, is doing an enormous amount of quiet work it has not really earned. There is an image I keep coming back to for it, and it is not gentle. A red dwarf habitable zone is like trying to live inside a boxing ring, while an opponent 4 times your size throws a haymaker at you every 4 hours, for your entire life, for billions of years. You might still be standing at the end of the round, there might still be a body in the ring, but the word habitable is carrying a lot of weight in that sentence, because whatever is left standing has spent a lifetime taking blows that would have flattened most of the population by the 3rd round. That is most of the lottery tickets we hold, 3 out of every 4. Most of the worlds we are currently studying, most of the candidates for life anywhere in the sky, are sitting inside a fight that never ends. There are exceptions. There are older, quieter red dwarfs that have settled down. There are worlds around calmer stars more like our sun, but those are rarer and harder to find, and they are not where most of the numbers are pointing. So let's ask our question, standing in front of the most common kind of world in the universe: is anyone home? And the honest answer is, probably, on most of them, no. And the ones where the answer might be yes are the ones clinging on in the narrow twilight of a world that is being hit over and over by a star that will not stop. The porch light around a star like TRAPPIST-1 is still on, but it flickers 6 times a day. The wiring keeps tripping. Every time you think you are about to see the house, the light surges so bright it blinds you, and then it goes dark again. So far we have been talking about whether a world can hold life at all, given its star and its place. But there is another problem, one we have brushed past, and it may be the quietest and the deadliest of them all. Even if a world does everything right, even if it holds its atmosphere and dodges the flares and sits patiently in the middle of its octave and grows something alive, there is still the question of when. That is where we have to look next. Here is the timing problem, and it is worse than it sounds. Suppose, for the sake of argument, that life is not even rare. Suppose that on a decent fraction of those Earth-like worlds, life did get going. The galaxy is more than 10 billion years old. 10 billion years of worlds catching fire and burning out at every possible starting time, on every possible schedule. Now think about how thin our own moment is inside that. Human radio, the only kind of signal we could send or receive across the stars, has existed for about 100 years. Recognizable human civilization, with cities and writing, is maybe 10,000 years old. Anatomically modern humans, 300,000, and the Earth has been habitable for about 4 billion years. So if you compress the whole span of Earth's habitable history into a single calendar year, the entire existence of our species shows up in the last 90 seconds before midnight on December the 31st. All of recorded history is the final second or two. Everything we have ever built, every civilization that has ever risen and fallen, all of it fits in the last breath of the year. Now picture a galaxy where every living world has its own version of that calendar, and each one started at a different time and will end at a different time. And on each of them, the loud part, the part where anything is broadcasting, thinking, reaching out, is only a few seconds long inside a year that is mostly quiet. The odds of 2 of those calendars overlapping in their loud seconds, of 2 worlds being awake and reaching out at the same moment, close enough to hear each other, are slim. Reach into the universe at random, and you would almost always pull out a world that either has not started its story yet, or finished it long ago, or never had one at all. Which means the silence we hear is not proof of an empty universe. It is at least partly proof of timing. Some of that quiet might be that nobody is out there, But a great deal of it is almost certainly that somebody was and is not anymore, and their moment and ours simply never lined up. There is a phrase for this that astronomers sometimes use, half joking, the Great Quiet. Not the Great Filter, which is a specific argument about what stops civilizations from growing. The Great Quiet is just the observation. The receiver is on. It has been on and pointed at the sky for as long as we have been able to listen, and the signal level is essentially zero and has been essentially zero the whole time. The library is real, the shelves are full, the lights are off. Whether anyone is still inside is a question we do not yet have a tool sharp enough to answer. And there is one more turn of the knife hidden inside the timing, and it comes from something you already know but rarely follow all the way to its conclusion. When you look up at the night sky, you are not seeing the sky, you are seeing a record. Every point of light you can pick out has been travelling toward you for some amount of time at the speed of light before it reached your eye. The sun you see is 8 minutes old. The nearest star's light is more than 4 years old. The light from the far side of our galaxy left tens of thousands of years ago. The light from the Andromeda galaxy, the faint smudge you can just make out on a dark night, has been travelling for 2.5 million years and left before our species existed. Every star is a letter, and the letters were all mailed at different times, and they happened to arrive at your eye together tonight, but they were not sent together. Some were sent last year, some were sent when the pyramids were being built, some were sent before there were any humans to send them. And here is what that means for our question. Every world we might ever detect, every atmosphere we might ever read for a fingerprint of life, is also a letter from the past. If a living world sits 60 light years away, the light we read tonight is 60 years out of date. If it is 1,000 light years away, the picture is 1,000 years old. For a planet whose atmosphere changes slowly, a few hundred years usually does not matter much, but push it out far enough and it matters a great deal. The light from a world 10,000 light years away tells us what its air looked like 10,000 years ago. Whole civilizations rise and fall in less than that. Whole living epochs begin and end. So when we finally point our best instruments at some promising world and read a signature that looks like life, we will not actually be asking whether anyone is home right now. We cannot ask that. The concept of right now does not even have a clean meaning across those distances. We will only be asking whether anyone was home at the moment the light left. Some of the letters in that enormous mailbox are from senders who are still there. Some are from senders who have moved, and some, we know for a fact, are from senders who died long before the letter ever arrived. There are stars in the sky tonight whose light is still travelling to you, even though the star itself is already gone, already collapsed or blown apart, and you cannot tell which ones they are, because the letter from a dead sender looks exactly like the letter from a living one. It is the same light. The sky we see is, in a real and literal sense, a memorial. We are reading mail. Some of it is recent, some of it is very old, and we have no reliable way from down here to check the postmark against the sender's pulse. So when we look up and try to figure out who is or is not out there, we are opening a mailbox full of letters of every age, from senders scattered across billions of years with no dates we can fully trust. We sort through them, we do our best, we make our maps. The maps are useful, but they are fundamentally maps of a place that may or may not still exist in the form the map describes. Hold on to that mailbox, because it comes back at the very end, and it comes back warm. But right now it lands cold. It means the universe might be full of life in the sense of all time, and nearly empty in the sense of right now, and both of those can be true at once, depending on how you take the snapshot. That is the third door, in its fullest and hardest form. Not empty, not crowded. An archive of moments, most of which do not overlap with ours. But there is a piece of this we have skipped, and we cannot go any further without facing it, because so far I have been quietly assuming that life shows up whenever conditions allow. That when a world has water and warmth and time, something takes hold, and we do not actually know that. We have never known that. That is where we have to look next. There is a question hiding underneath all of this that we have to answer before we go further. because otherwise the whole search sounds hopeless. If a living world is out there, sealed off by distance and by time, how could we ever know it is alive without going to it? We are never going to fly to most of these worlds. We have said that plainly. So what is the point of looking at all? And the answer is that we do not have to touch a world to read it. We read its air. When a planet passes in front of its star, a thin sliver of that starlight filters through the planet's atmosphere on its way to us, and the gases in that air each absorb their own specific colours out of the light, leaving a pattern of dark lines, a kind of barcode. Read the barcode and you can tell what the air is made of across light years without ever leaving home. We are already doing this. It is how we read the deuterium ghost that told us Venus once had oceans, and it is how, in the coming years, we are going to start reading the atmospheres of small rocky worlds around other stars. And here is what makes that powerful. Some gases on a rocky world are very hard to explain without life. Oxygen is the clearest example. Oxygen is so reactive that it does not last on its own. Left alone, it bonds with rock and with other gases and disappears within a few million years. So if you find a rocky planet with a lot of free oxygen in its air, something has to be making it constantly to keep it there. On Earth, that something is life. Photosynthesis, the green things, and before them the microbes, pumping oxygen into the sky faster than the chemistry can pull it out. Find oxygen on a distant rocky world, and you have found something that needs an explanation, and life is one of the leading ones. Better still, find oxygen and methane together in the same atmosphere at the same time. Those two gases destroy each other. They should not coexist. If you see both in quantity, then something must be producing both fast, right now, keeping the whole system out of balance. That kind of chemical disequilibrium, an atmosphere held in a state it has no business being in, is one of the strongest fingerprints of a living world we know how to look for. It is in a sense the signature of a planet breathing. The instruments to do this seriously are only now coming online. The James Webb Space Telescope is already reading the atmospheres of some worlds. A generation of enormous ground-based telescopes with mirrors tens of meters across is being built right now and will come into service over the next decade. And they are designed, in part, to do exactly this, to sift the air of small rocky planets around nearby stars for the fingerprints of life. So we are, genuinely, on the edge of being able to point at a specific world dozens of light years away and say, with real evidence, that its air looks alive. But sit with what that would and would not be. Because here is a thought experiment that captures our situation exactly. Imagine an astronomer on some other world, a few hundred light years away, studying our solar system. They have good telescopes, they watch the planets cross their star, they read the atmospheres of the rocky ones, and when they look at Earth, they find oxygen and methane and water vapor and ozone, a whole atmosphere held out of balance in a way that by their best models looks like a biosphere. They write a paper, they put Earth on the candidate list. And then what? They cannot come here, they cannot send a probe across that gulf, they cannot bring back a sample, the distance is too great, and the expanding universe is quietly making it greater. They will know that Earth probably has life. They will never be able to confirm it, never see what that life looks like, never trade a word with it. They will spend the rest of their civilization's existence with our world as a marker on a chart, a promising entry on a list of candidates, a fingerprint they can read but never close. That is exactly where we are about to be, with the 6,000 worlds we have found, and the tens of thousands we will find, and the hundreds of billions we suspect are out there. We are going to compile a list. Some of the entries will probably be right. Some will be false alarms, oxygen made by some chemistry we did not think of, disequilibrium with no life behind it. And for almost all of them, we will never get to find out which is which. We will read the mail, we will recognize a few of the handwritings as alive, and we will never, ever get to write back. A living world we can read and never reach is still, in the end, a living world lost to us in every way except the one that matters least, which is that we know it might be there. There is a tendency when we talk about habitable worlds, to quietly treat habitable and inhabited as the same word. They are not. They are not even close. Habitability is a description of conditions. Inhabitation is a description of what is actually living there. The first is a kind of resume. The second is whether anyone ever showed up to do the job. And I have to be honest with you about the gap between them, because this is exactly the place where it is easy to overclaim, and I do not want to do that to you. Here is what we actually know about life starting on a world. We know it can happen. We know that because we are standing on a world where it happened. That is one example. That is the entire data set. 1. We do not know how often it happens when conditions allow. We do not know if it usually happens or almost never happens. We do not know how to look at a world from the outside and tell whether life ever appeared on it or not. We have hints. We do not have answers. And even the one example we have is stranger than people assume. On Earth, there was a gap between the planet becoming habitable and the planet becoming inhabited. Liquid water on the surface goes back at least 4 billion years, possibly 4.5. The earliest solid evidence of life shows up somewhere between 4 billion and 3.5 billion years ago. So somewhere between 0 and 700 million years passed between the Earth being able to support life and the Earth actually having it. And we do not know what happened in that gap. Was life almost instant, arriving the moment conditions were right, with the apparent delay just an artifact of a rock record that does not preserve the earliest chapters? Or did it take hundreds of millions of years of chemistry, running and rerunning, before the first self-sustaining, self-copying system finally caught? The answer to that one question would tell us more than almost anything else about whether life is common or vanishingly rare, and we cannot answer it. The earliest fossils are debated. The earliest chemical signatures are debated. People publish papers moving the dates in both directions every year, and the field does not settle because the problem is genuinely hard and the evidence is genuinely thin. What we can do is look at how hard the first step actually is. Going from non-living chemistry to a living cell, a thing that stores information and copies itself and passes changes down and holds itself together inside a membrane and pulls energy from its surroundings all at once on a world where it has time to assemble, is not a trivial thing. There are serious biochemists who think it is so hard that it might happen only once in the entire lifetime of a galaxy, by sheer statistical luck. And there are equally serious biochemists who think it is so favourable that it should happen on any world with the right chemistry within a few million years. Both groups are smart, both are looking at the same evidence. They disagree because the problem is genuinely open, and I am not going to pretend to you that it is settled, because it is not. A good way to hold this is the difference between dropping a seed on bare stone and dropping a seed in good soil. Drop a seed on bare stone and you can be fairly sure nothing comes of it. The conditions are wrong, the seed just sits there. That is most of what we have found in the catalogue. The scorched and airless and frozen worlds, where the seed, whatever became of it, was never going to grow. But here is the part that takes a moment to absorb. Even if you drop the seed in good soil, you do not automatically get a tree. You might get nothing. The seed might be the wrong kind for the soil. It might get eaten before it sprouts. The soil might be good in every way you tested, and quietly wrong in some way you did not think to check. Good conditions are necessary. They are not sufficient. The seed still has to take. Habitability is the soil. Whether anything actually grew in it is a separate question, and it is not one we know how to answer from here. The universe is dropping seeds across hundreds of billions of worlds. We do not know what fraction of them germinate. We have exactly one tree, and no idea whether the field around us is full of other trees we simply cannot see, or whether it is mostly empty soil with a single tree standing in it. And Mars, the world we started with, is the most painful case of all, precisely because it sat there with everything it needed for a long stretch of time, and we still cannot tell. It had liquid water for hundreds of millions of years. It had an atmosphere, a magnetic field for a while, the chemistry, the energy. By every measure we can apply from a distance, Mars was a world that should have been able to support life in the very same era when life was getting started on Earth. Did it? We do not know. We have a tube. We have a rock with markings in it that on Earth would be a textbook signature. We have the careful, hedged language of the people who studied it, which is the language of suspicion, not confirmation. And we have at the moment no way to bring that tube home. Even if we retrieve it, even if the laboratory confirms beyond doubt that something once lived there, that gives us a second example in one solar system. And from two examples we still would not know the rate at which life appears across the universe. We would have made one of the most important discoveries in our history, and we would still be standing in the dark about the one number that matters most. So we have to sit honestly in that uncertainty. It might be that life is common, and the sky really is an archive of 1 trillion living and dead worlds. It might be that life is so rare that the Earth is close to alone, and the seed almost never takes. We do not know which. And not knowing is not a failure to be embarrassed about. It is the actual situation, stated plainly. But there is one more thing we do know, and it points in a direction most people never expect, because we have been so busy asking whether life can start out there, that we have not looked hard enough at how easily life ends, even here, on the one world where we know for certain that it took. Because the Earth, the planet we treat as the steady one, the success story, has come far closer to going dark than most people realize, more than once. And once, it very nearly killed itself by learning to breathe. That is where we have to look next. The standard story about Earth is that we got lucky. The sun is calm, the orbit is stable, the moon steadied our tilt so the seasons do not swing wild, the magnetic field held, the atmosphere held, the water held. We had time, life showed up, life stuck around, and here we are, telling each other how habitable our planet is, because we get to. And that story is true in its broad outline. Earth is, by every measure we can apply, an unusually steady world. 4 billion years of conditions that let life keep going in some form, without ever fully resetting. That is not nothing, that is the biggest thing. But it is not the whole picture, because Earth has come very close to going dark more than once. The fossil record holds evidence of 5 major mass extinctions, plus a long list of smaller ones. Events where so much of the living world died off in a geologically short window that the record itself goes thin. You can read the summary of a mass extinction in a single afternoon, even though the recovery took millions of years, and there is a reason for that. There just is not much to say. The fossils stop, the pollen stops, the chemistry of the rock shifts, the lights for a moment go out. The worst of the 5 is one called the Permian-Triassic extinction, sometimes just called the Great Dying, and the numbers are almost hard to believe. Roughly 96% of marine species died off in that event, around 70% of land vertebrates. Insects, which are famously hard to kill, had the only mass extinction in their entire history. The fossil record on either side of that boundary looks like 2 different planets. Almost nothing made it across. The trigger, as best we understand it, was a vast, sustained series of volcanic eruptions that flooded the air with carbon dioxide, acidified the oceans, drained the seas of oxygen, and drove the climate up by something like 10 degrees in a geological blink. It took the planet somewhere between 5 and 10 million years to fully rebuild afterward. 5 to 10 million years where life on Earth was, in a real sense, on life support, hanging on, slowly reassembling itself from the survivors. And that is the worst one we have a good record of. But it is not the worst thing that ever happened to life on Earth. The worst thing happened so long ago that it barely left a fossil record at all, because it happened to single-celled organisms more than 2 billion years before any of the famous extinctions. It is called the Great Oxidation Event, and it is the strangest catastrophe in the planet's history, because it was not caused by an asteroid or a volcano or anything from outside. It was caused by life itself. Here is how it went. For roughly the first 2 billion years of life on Earth, the dominant organisms did not use oxygen. There was almost no free oxygen in the air to use. The early atmosphere was nitrogen and carbon dioxide and methane and other things, and oxygen was not on the list, because oxygen is so reactive it bonds with almost everything and does not hang around unless something is constantly producing it. Then a particular group of microbes, the ancestors of what we now call cyanobacteria, evolved a new trick. They learnt to do photosynthesis using water, taking sunlight and water and carbon dioxide and building sugars and releasing, as a waste product, free oxygen, pure oxygen gas. And at first it went slowly. The oxygen they made got soaked up by iron dissolved in the oceans and locked into rock, and for a long time the oceans absorbed it almost as fast as it was produced. You can read that stage directly in the ground, in the banded iron formations, those layered red and dark rocks you find in places like Western Australia. Each band a chapter in the slow story of life poisoning the chemistry of its own oceans. Eventually the sinks filled up, the iron ran out, and the oxygen had nowhere left to go but up, into the air, where it began to accumulate. And for most of the life on Earth at the time, that was a catastrophe. Oxygen, to an organism that evolved without it, is a poison. It is a reactive molecule that tears cellular chemistry apart. The microbes that had built the entire biosphere over 2 billion years had no defense against it. The rise of oxygen, slow in geological terms but fast in evolutionary ones, killed off something like 80 to 99% of all life on Earth at the time. The number is hard to pin down because the record is so thin, but the evidence converges on a catastrophe of almost unimaginable scale. The first true mass extinction in the planet's history was not a rock from space, it was the air. It was life inventing the thing that you and I now require to stay alive, and in the inventing, nearly wiping itself out. Sit with that one for a second, because it changes how you should think about all of this. Everything you have breathed today is part of the same atmosphere that 2.5 billion years ago was a planetary disaster. The oxygen keeping your brain running is the same molecule that exterminated most of the biosphere the first time it appeared in quantity. It was a poison in its day. It became a fuel only later, after enough organisms evolved to handle it. And the reason complex life is possible at all, the reason animals like us exist, is that oxygen is rich in energy and our kind of metabolism can pull a lot of usable power out of it. None of that happens without the Great Oxidation Event. None of it happens without life nearly killing itself. And the recovery took a staggeringly long time. Between that catastrophe and the appearance of the first complex, multicellular life, there is a stretch of about 1 billion years so uneventful that geologists actually call it the boring billion. 1 billion years where the biosphere, knocked flat, spent the whole time just catching its breath. So the picture of Earth as a stable, life-friendly planet is true, but only in the broadest sense. Yes, the planet has held life for 4 billion years, but within that long continuity, there have been at least 5 major resets, plus the oxygen catastrophe, plus who knows how many near misses that left no clear mark. Almost everything alive has died, multiple times, in different ways, for different reasons. The thread of life on Earth is not a thick, unbreakable rope. It is a series of thin filaments, some of which snapped, with the surviving strands carrying everything forward each time. Life here did not stroll through 4 billion years untroubled. It threaded through one narrow bottleneck after another, and more than once it very nearly did not make it. And the relevance of that to the whole question is straightforward and unsettling. If life on Earth, on the one world we are calling the success story, has almost been wiped out again and again, and once nearly killed itself with its own waste, then what are the odds that life elsewhere navigated all of those same transitions successfully? What are the odds that a young world out there evolved photosynthesis and then choked on its own oxygen and never recovered? That a world had its volcanic epoch, or its great glaciation, or its runaway warming, and the recovery simply never came? We have one example of life surviving its own evolution. The fact that we exist proves it can happen. The fact that it so nearly did not, on the only example we have, tells us it might fail far more often than it succeeds. Which means that even the worlds where the seed took, where life genuinely began, are worlds where the lights could very well have come on, flickered through a few crises, and then gone out for good, long before anyone here ever looked up to check. The library gets darker the longer you stand in it. So we have followed the whole chain now. Most worlds are stones that were never going to live. Of the ones that could, most orbit stars that will not let them settle. Of the ones that settle, most are in the wrong era, their moment out of sync with ours. And even the ones that do everything right, that catch fire and hold on, can be snuffed out by their own success. Which brings us, finally, to the hardest turn of the night. Because suppose we set all of that aside. Suppose that, against all of it, a living world is out there right now, at this very moment, in tune, in its era, alive. The second half of our question has been waiting in your back pocket this whole time. Could we ever actually reach it? That is where we have to look next. So let's grant it. Let's grant the thing that everything else tonight has been trying to take away. Somewhere out there, a world is alive right now, in tune, in its era, dodging its stars' worst flares, holding its air, its oceans liquid, something breathing under its sky. The rarest thing in the universe as far as we can tell, and we are handing it to ourselves for free. Now ask the second half of the question, the one you have been carrying in your back pocket since the very beginning. Could we ever reach it? Could we ever stand on it, or trade so much as a single word with whatever lives there? And this is where the story turns from biology to something colder and more final, because the answer, for almost every living world that could possibly exist, is no, and not a no that better technology fixes, a permanent one. Start with the nearest possible case, the friendliest version. The closest star to our own, Proxima Centauri, is 4.24 light-years away. The fastest object our species has ever built, a probe called Voyager, launched in the 1970s and still coasting outward, moves fast enough to cross the United States in about 4 minutes. And at that speed, it would take more than 70,000 years to reach that nearest star, if it were even aimed there, which it is not. 70,000 years, longer than our species has looked anything like it does now. And that is the nearest star, which as far as we know does not have a living world around it at all. Push out to a system like TRAPPIST-1, with its 7 rocky worlds, and you are 40 light-years away, and the travel times stop meaning anything a human life can hold. But set even that aside, because there is a deeper problem than slowness, and it is the one that turns a hard no into a permanent one. The universe is expanding. Not the galaxies flying apart through space, but space itself, the emptiness between the galaxies, stretching, growing, everywhere at once, carrying distant things away from us. And it is not doing this at a steady pace, it is speeding up, which means that a living world out there is not a boat tied to a dock, waiting for us to walk down the pier and reach it. For anything far enough away, it is a boat already pulling out to sea, and the water between us is lengthening faster than any ship could ever cross it. We could leave tonight at the absolute fastest speed the universe permits anything to travel, the speed of light itself, and for the overwhelming majority of the galaxies out there, we would never arrive. The gap grows faster than we could close it. When you actually run the numbers of all the galaxies we can see in a deep photograph of the sky, more than 19 out of every 20 are already beyond our reach, forever, right now, tonight. Not too far for today's rockets, too far for light, sealed off by the shape of a growing universe, in a way no speed and no patience and no future breakthrough can ever undo. And every one of those unreachable galaxies holds 100 billion stars, and whatever worlds go with them, and whatever might, right now, be alive on any of them. So think about what that does to our question. It means the losses we have been counting all night were never only rock and empty air. Every one of those unreachable galaxies, every one of the 19 in 20 already gone, may carry living worlds on it. Worlds with oceans, or something like oceans. Worlds where a tide comes in and goes out. Worlds where, for all we know, something is looking up at its own night sky right now, and wondering exactly what you are wondering. And we can never reach a single one of them, not slowly, not with a better engine, never. We can see the light of the galaxy they might live in. We can measure it, photograph it, put it in a catalogue, and we can never send them so much as one particle that would arrive, and they can never send us one, because the road between us lengthens faster than light can walk it. 2 living worlds, in the same universe, sealed off from each other forever by nothing but the shape of space. That may be the loneliest fact in all of physics, and it was true long before there was anyone here to feel it. which is where the title of tonight becomes something very specific and very literal. The last living world may indeed be beyond humanity's reach, not because there is one final world glowing alone at the end of the universe, but because of all the living worlds that may exist, the overwhelming majority are already unreachable, and the reachable set is not holding steady, it is shrinking. As the expansion accelerates, more of the sky crosses over the line, out of reach, every single day. The number of living worlds we could ever actually stand on only goes down. It has been going down the whole time. And when you follow that number all the way in, past the galaxies we can never reach, past the ones drifting out of reach as we speak, in through our own small neighborhood of galaxies where we have not yet found even one other living world, and you keep going, you arrive, finally, at the one living world we are absolutely certain of, the one guaranteed to stay within reach no matter what the expansion does, because it is not out there across the dark at all. It is here. It is the ground under your feet. I want to be careful and honest here, the way I have tried to be all night, because it is easy to slide from a real fact into a bigger one it does not quite support. We do not know that Earth is the only living world. We do not know that there is not another one closer than we think, in our own galaxy, that we simply have not found yet. Life may be common. Our own neighborhood of galaxies, the ones gravity holds close enough that the expansion can never carry them off, is bound to us. And if there is a living world somewhere in that neighborhood, then in the deepest, longest sense it stays reachable, in principle, forever. So I am not telling you the Earth is alone. What I am telling you is narrower and harder to shake. Of every living world we could ever, even in principle, reach, the one we are certain exists, the one guaranteed to remain within our grasp no matter what, is the one we are already standing on. Earth may be, in the most practical sense there is, the last living world humanity is ever guaranteed to touch. Not because life is rare, we do not know that, but because reaching is the thing that is running out. The door is closing on everything else, one galaxy at a time, and the one living world it can never close on is the one we woke up inside. Picture it the way the cameras on our outbound probes saw it, when they turned around for a last look on their way out of the solar system, and caught the Earth as a single pale point of light, smaller than a pixel, hanging in a stray sunbeam. From far enough away, our entire living world is exactly that. One lit window in the dark, one porch light still on, with someone actually home, and it is the only one, out of all the countless windows scattered across a universe that is mostly already unreachable, and mostly, we suspect, already dark, that we are certain we can still walk up to. Everything the old dream of the frontier ever really wanted, another world with something alive on it, we already have. It has been under us the entire time. We went looking for the last living world at the edge of the sky, and we were standing on the answer the whole time we searched. That does not make the sky less worth looking at, it makes the ground more worth standing on. And it changes the shape of everything we have walked through tonight, the dead worlds, and the flaring stars, and the mismatched calendars, and the letters from senders who are already gone. Because it turns out we have been circling, this whole time, towards something that is, quietly, not a loss at all. Let's talk about the one living world we are standing on, and what it actually means to be here, now, awake, on the porch with the light still warm. There is an instinct when we talk about all of this, to position Earth as the exception, the one that worked, the lucky planet in the lucky orbit around the lucky star, with the lucky moon, and the lucky magnetic field, and the lucky biology, where everything broke our way, and everything held, and we sit here, 4 billion years in, breathing the same air that once nearly ended the world, looking up at planets that did not make it, and feeling, on some level, that we are simply not on the same list as them. But we are on the same list. Earth is not the exception. Earth is the one in the middle. Mars showed us the cold ending. Venus showed us the fire. Earth is showing us what the during looks like, the warm afternoon in the middle of the story, the part that only ever lasts a thin slice of a world's existence. The fact that we exist at this particular moment is not because Earth is a fundamentally different kind of world than Mars or Venus. It is because we showed up at the right time, inside the window, while it is still open. And here is something worth stopping on. because it is easy to skip past. Earth as we know it, this specific world with this specific chemistry and climate and weather, is not simply a place where life happens to live. It is a system that life built and life maintains. The oxygen in the air is made by living things. The balance of gases that keeps the temperature livable is held by living things. The composition of the soil, the chemistry of the ocean, all of it is actively kept in place by the biosphere that lives in and on and around it. Remove the life, and you do not just have an empty Earth, you have a different planet orbiting in the same place, but fundamentally changed. The oxygen would react away and vanish within a few million years. The ozone would go with it. The whole living signature that makes Earth obviously alive from across space would fade. The planet and its life are a single coupled system. Change one and you change the other, which means the loss of life on a world is never only a biological event, it is a planetary transformation. When Mars went quiet, Mars became a different planet. When Venus's oceans boiled, Venus became a different planet. And the Earth we love, the blue and green and white one, only exists because something is alive on it to keep it that way. Earth is life, not a stage life stands on, the thing itself. That is what we mean, in the end, by a living world. Not a rock at the right distance from a star. A rock that has been so thoroughly taken over by life that you cannot separate the two anymore, where the air and the water and the stone all carry the fingerprints of the living things that shaped them. And as far as we can confirm, tonight, with everything we actually know, rather than everything we hope, there is exactly one of those in the entire universe. One world where we can say, with certainty, that this happened and is still happening right now under our feet. There may be others, there may be many, but this is the one we have, the one we are sure of, and the one, out of all of them, that we can never lose to the expanding dark because we are already here. There is something genuinely strange about being the species that figured that out. None of the other creatures on this planet know any of it. The dolphins do not know, the crows do not know, the trees do not know. Only we have done the math, read the rock record, measured the light of dying stars and dying worlds, and worked out with real precision where we sit in the long life of our own planet and our own universe. Only we know that the window is open and that it will not stay open, and that we are early enough to see all of it while the seeing is still possible. And that knowledge is recent. People have only held it with anything like this clarity for a few decades. Most people, most of the time, still walk around imagining Earth as the permanent, steady, given thing, and space as an empty backdrop, and life as either everywhere or nowhere. You know better now. You know it is the third door, an archive of worlds, most of them dark, a few of them lit, and one of them, the one you are standing on, still warm. And once you know that, the night sky becomes a different thing to stand under. It stops being a question about who our neighbours are and becomes something closer to a question about when. When did the light on each of those worlds come on? When did it go out? Are any of them, somewhere in the dark, having their own long warm afternoon right now, at the same moment as ours, looking back across the same dark at our small point of light, wondering the exact same thing? That is a different way to see the sky. It is less a search for company and more a survey of moments, some of which overlap with ours, most of which do not. The galaxy in that picture is not a city of neighbours, it is something more like an archive. Each star, each world, its own slice of time, with its own beginning and its own end, and the slices mostly do not line up. We are walking through the archive. We can see only the slices whose light happens to reach us now, and we can never visit the ones behind the glass, but we can read them. We can stand in the dark library and run our hands along the spines and know that every one of them was real, that somebody or something filled these shelves, even if the writers are long gone and the lamps are long out. Now go back to the mailbox. Remember the mailbox, full of letters of every age, from senders scattered across billions of years, some still home, some long gone, and no way to tell which from the envelope. It landed cold when we first opened it, because it meant the worlds we see may already be dead, that we are reading mail from the deceased and cannot know it. But there is a warm side to that same mailbox, and it is the side that is true right now, tonight, at this exact moment in the life of the universe. The letters are still arriving. Ours is not the empty mailbox, ours is the full one. The light of 100 billion galaxies is falling on the Earth this very second, some of it, if you are outside under a dark sky, falling on you. The photons that left the Andromeda galaxy 2.5 million years ago, before there were any human beings anywhere, are finishing their journey right now on your eye. The light of worlds we could never reach, worlds that may be alive and may be long dead, is still streaming down onto our telescopes, still carrying its picture of a cosmos, most of which is already, in one sense or another, beyond us. We are standing in the one window when all of that mail is still being delivered, and that window will not stay open forever. Because the universe is expanding, and the expansion is speeding up, and far in the future, tens of billions of years from now, the galaxies beyond our own small-bound neighborhood will have receded so far, so fast, that their light can no longer cross the growing gap to reach us at all. One by one, the distant lights will go out of the sky, not because anything happened to them, but because the road between us grew too long for even light to travel. And a civilization that arises in that far future, however brilliant, however patient, will look up and see only their own island of stars, alone in a perfect and featureless black, and they will conclude, with every piece of evidence on their side, that this is all there ever was. They will have no way to know that the sky was once full, no way to discover that trillions of other worlds once hung overhead, no way to even suspect that a great archive of light was ever there to read. They will inherit a silence so total that they cannot recognize it as a silence. Their mailbox will be empty, and always will have been, as far back as their history goes, and they will have no way of knowing that a post office ever existed at all. We are not those future minds, we are their exact opposite. We are alive in the narrow, early, extraordinary window, when the letters are still coming in, when the sky is still full, when the whole archive is still overhead and still legible for anyone willing to look up. We can still find the faint smudge of Andromeda with our own eyes. We can still read the light of dying worlds and boiling oceans and stars that ended before our species began. We can still hold, in our minds, the true shape of the cosmos, the dead worlds and the living ones, the great quiet and the mailbox and the archive, all of it, because we happen to exist early enough that the door, though it is closing, has not yet closed on the view. Almost every observer who will ever exist across the entire future of the universe will live in the long dark after the sky has emptied, knowing far less than we do, cut off from the evidence we still hold in our hands tonight. We are not the latecomers, we are the ones who got here in time, and that reframes every dark thing we have counted tonight. Yes, most worlds are stones. Yes, most of the living ones, if they exist, are already beyond our reach and always were. Yes, the last living world we are guaranteed to touch is the one under our feet. But we are among the vanishingly rare minds that are here early enough to find all of that out, early enough to see the full sky before it goes, and to understand what it means that it is going. Later minds would trade almost anything for the view we get for free, just by walking outside on a clear night. I want to spend a little time in the place we have arrived at, because the texture of it matters more than any single fact we have covered. The facts were only ever scaffolding. The shift in how you stand under the sky is the actual building, and the shift is this. When you really absorb that most worlds are stones, that most habitable zones close, that most stars are not gentle, that most living worlds, if they exist, are out of sync with us in time and out of reach in space, and that even our own world is well past the middle of its own long afternoon, you might expect to feel smaller, or sadder, or more alone, and there is a version of that feeling, and it is honest, and I am not going to talk you out of it, but there is another feeling underneath it that I find truer the longer I sit with it, and it is not pessimism, and it is not optimism. It is something quieter. It is what you get when you let the actual scale of the situation arrive, without trying to make it more comforting or more frightening than it is. The way I have come to think about it is as a long evening. The day is over, the evening is here, the light is still warm, The window is still open. The night is coming, but the night is not here. We get to sit on the porch of this planet, while it is still possible to sit on the porch of this planet and watch the sky and read the mail and wonder who else on some other porch under some other star might be doing exactly the same thing while their light is still warm too. The window will not stay open. That is true. It is also true that the window is open now, and what matters about an open window is whether it is open in the moment you are standing in. And Earth's window is open. The oceans are still liquid. The air is still breathable. The magnetic field is still up. The planet is still doing the slow, patient work of being a world that supports life. None of that is broken. If I had to choose an image for it, it would be a particular kind of evening. The kind where the air has finally cooled after a hot day, where the light is going golden, where you know it is going to get dark, but it is not dark yet, and you can sit outside and not feel cold and not feel hot, and the ordinary small sounds of the world go on around you. That kind of evening does not last. It cannot. The dark is coming, but the dark is not here. That is the moment we live in. Earth is having one of those evenings, and the evening is hundreds of millions of years long, and we get to be inside it for a sliver of that span, and the evening is good, and the evening is warm, and the evening is going to end, and none of those facts cancels out any of the others. And here is the thing I find myself coming back to, the thing that does not make it into most of the science. The fact that Earth is past the middle does not change anything about how good the evening still is. The kitchen window is still lit. The voices inside the house have not stopped. The seasons still come. The rain still falls. Whatever is coming is coming. But tonight is not that. Tonight is one of the nights inside the open window. Notice the sound of it, wherever you are. The wind, if there is wind. The rain on a roof, if it is raining. The breathing of a person beside you, if there is a person beside you. The hum of the refrigerator. The distant sound of a road. The small ordinary noise of a world that is, right now, this second, still alive. That sound has been continuous, in one form or another, for 4 billion years. That sound is the gift. That sound is what we actually mean by habitable, once you strip all the definitions away. It is the sound of a living world, and there is, that we can confirm, exactly one place in all the dark where you can hear it, and you are standing in it. Mars is silent. Venus is silent behind its burning clouds. The library is dark and quiet and full of books nobody is reading. And here, tonight, on this one small pale point of light, the sound is still going. There is one more thing worth understanding about life before we finish, because it cuts both ways and it matters for every dark world we have talked about. We keep picturing life as something that lives on the surface, under an open sky, in the light, but most of the life on Earth does not live like that at all. By sheer weight, the majority of living things on this planet are microbes, and an enormous share of them live nowhere near the surface. They live in the deep, in solid rock, kilometers underground, in the dark, in the heat and the crushing pressure, feeding on chemistry seeping out of the stone. Some of them so slow that a single cell might divide once every few thousand years and go on living for tens of thousands. There are microbes thriving in water hotter than the boiling point at the bottom of the sea, clustered around volcanic vents where sunlight has never reached. There are organisms that survive being frozen solid, being dried to dust, being blasted with radiation that would kill almost anything else instantly. Life, once it takes hold, is astonishingly, stubbornly hard to fully erase. It does not sit politely in the comfortable zone. It crawls into every crack and edge and extreme it can find, and it holds on. And that tells us two things, pulling in opposite directions. The first is hopeful. It means that habitable may be a far wider word than a warm blue sky. It means that a world we would write off from a distance, a frozen moon, a scorched rock, a planet that lost its surface long ago, might still hold life somewhere in the dark, underground, under ice, in some sheltered pocket where the surface catastrophe never reached. It is exactly why the frozen moons of the outer solar system are suddenly so interesting. Life does not need the porch light, it can live in the cellar, so the dead worlds we have toured tonight might not be entirely dead, not all the way down. Mars, whatever happened to its surface, may still have something living deep in its crust, where a little warmth and a little water might linger. We do not know, but we have learnt enough about how tenacious life is that we can no longer assume a quiet surface means an empty world. But the second thing cuts the other way, and it is the harder one. That kind of life, the deep, patient microbial kind, is silent. It does not build radios, it does not broadcast, it does not light up its sky or send out signals or leave any mark we could read from across the dark. A world could be alive, genuinely, richly alive, in its deep rock and its buried oceans for billions of years and give off no sign whatsoever that we could detect from here. It might not even change its own atmosphere enough for us to read a fingerprint in the air. So the universe could be more alive than we will ever be able to prove, full of quiet, hidden biospheres tucked away in the dark of 1,000 worlds, none of them ever making a sound we could hear. The great quiet, once again, not the silence of an empty universe. The silence of a universe that may be humming with life too deep and too far and too quiet to ever reach us, which only sharpens the one thing we can say for certain. There is one world where we know the life is not hidden, not silent, not buried out of reach. One world where it is up here in the light, breathing into the sky, making a sound we can hear, and we are standing on it. And I do not want to leave you with the impression that the search is over, or that the answer is already in, because it is not, and the honest state of things is more open than any tidy ending would suggest. We have barely begun to look, even in our own backyard. We treated Mars and Venus as the two dead worlds next door, and by the old definition of habitable, the surface where liquid water can sit under an open sky, they are. But life may not need the open sky. Right here in our own solar system there are worlds we have hardly touched, where the conditions for some kind of biology may exist in places we never used to think to look. There is Europa, a moon of Jupiter, wrapped in a shell of ice, with an ocean of liquid water underneath, kept warm not by sunlight, but by the constant flexing of Jupiter's gravity. An ocean that may hold more water than all of Earth's seas combined. There is Enceladus, a small moon of Saturn, actively spraying plumes of water vapor into space through cracks in its frozen surface, which means there is a liquid ocean under there too, venting into the dark, and we have flown a spacecraft straight through those plumes and found the chemistry of a habitable place. There is Titan, Saturn's largest moon, with a thick atmosphere and lakes of liquid methane on its surface, and the possibility of a chemistry so different from ours that it might be a kind of life we would barely recognize. None of these is a world with a warm blue sky. All of them are places where the ingredients for some sort of biology may be sitting right now, under the ice, in the dark, in our own solar system, and we have only started to check. So the library is not fully mapped, even the shelf closest to us. The sample tube on Mars is still up there, waiting, the most consequential rock our species has ever handled, and one day we will bring it home, and the laboratory will either confirm that something once lived on the world next door, or tell us those markings were chemistry all along. Either answer would be one of the most important things we have ever learnt. If it is life, then life started twice in one solar system, and if it can happen twice here, it can happen almost anywhere, and the whole sky tilts toward being full. If it is not, then we tighten our estimate of how rare the whole thing might be. We are, right now, in the middle of finding out. And that is a strange and specific kind of privilege. Every generation of humans before us lived and died without any way to answer the question at all. They could look up and wonder, and that was all. We are the first ones with the tools to actually check, to fly through the plume, to drill the rock, to read the fingerprint of an ocean in the air of another world 60 light years away. We may not get the final answer in our lifetimes, but we are the first ones who get to look properly, and that alone puts us somewhere no one has ever stood. But whatever that tube turns out to hold, whatever we eventually find under the ice of Europa or in the air of some distant world, one thing about tonight does not change. Every other living world, if it is out there, is either a fingerprint we can read but never confirm, or a light we can see but never reach, or a moment that already passed before we looked. The one living world we can walk on, the one we can touch, the one we can hear, the one whose sound has been going for 4 billion years and is going right now, is the one we are already standing on. That is not a small thing to be standing on. That might be the largest thing there is. And there is a quiet consequence of all this that is worth saying plainly, without turning it into a lecture, because it follows directly from everything we have walked through. If the one living world we are certain of, and the one we are guaranteed to be able to reach, is the one under our feet, then it is also the one thing in the entire cosmos that our choices actually touch. We cannot save a dying world 60 light years away. We cannot warm Mars back to life, or cool Venus, or reach across the expanding dark to a world we can only read as a fingerprint in the air. Those are beyond us, all of them, forever. But this one is not beyond us, this one we are standing on. We have seen tonight how many ways a living world can end. The core cools and the shield falls, the star brightens and the oceans boil, the window slides shut. Life even poisons itself and nearly goes out. The universe has a long, well-documented habit of turning living worlds into quiet ones. And we are the first form of life on this planet, and perhaps a rare form anywhere, that can see that pattern coming, understand it, and hold in our own hands, some say over how our own window plays out. That is not a burden the dolphins carry, or the crows, or the trees. Only we have done the math. Only we can look at Mars and Venus and read them as a warning rather than a curiosity. So the point of a night like this was never to make you feel small, or doomed, or alone in a graveyard of dead worlds. It was to turn you back around. We spend so much of our looking pointed outward, searching the dark for another living world, another porch light, someone else out there, and the whole search keeps quietly pointing back to the same place. The rarest thing we know of, a world that is genuinely, richly, audibly alive, is not a distant hope we might one day confirm. It is the ground you are sitting on. It was here the entire time we were scanning the sky for it. And of all the things you could do with that knowledge, the simplest and the truest is just to let it change, a little, how it feels to be here. To notice that the thing every frontier story ever promised, a living world you can actually stand on, is not out past the stars. It is the one you woke up on, warm and breathing and yours, for this long, early, open evening that will not come again. There is a lonelier possibility woven through all of this, and honesty means naming it too. It may be that the silence is not only a matter of timing and distance, it may be that we are early. The universe is 13.8 billion years old, which sounds ancient, but the era of stars and worlds is only getting started. Most of the stars that will ever exist have not been born yet. The small, long-lived red dwarfs will keep burning and keep making worlds for trillions of years to come. On that timescale, we are not late arrivals wandering through the ruins of a party that already ended. We may be among the very first guests, showing up while the lights are still being turned on. And if that is true, then the silence overhead is not the silence of a graveyard after all. It is the silence of a morning before anyone else is awake. Nobody is answering because there may not yet be many others to answer, not because they all came and went, but because the whole long story of life in the cosmos may be closer to its beginning than its end. Whether that lands as a comfort or as a weight depends on how you hold it. There is something lonely in the thought that we might be among the first, that the receiver has been on all this time, and the line is quiet because there is almost no one on the other end yet. But there is also something in it that is close to responsibility, close to meaning. If living worlds are rare, and awake ones rarer still, and we are early, then the thing under our feet, the one lit window with someone home, is not just precious because we happen to live on it. It is precious because it may be one of the very few places in the entire universe, so far, where the sound of a living world is playing at all. We do not know if that is true. We may never know, but it is allowed. It is one of the shapes the evidence permits, and it changes the weight of an ordinary night under the sky. You are not just standing on the one living world we are sure of. You might be standing on one of the first. So let's come all the way back to where we started. There is a rock sitting on the surface of Mars right now, sealed in a metal tube about the size of a piece of chalk, with small dark markings scattered through it that on Earth would be the first thing you would point to and call life. It is sitting on a world that went quiet 3.5 billion years ago, a world that had its own long warm afternoon, its lakes and its rivers and its thick sky, and then lost all of it when the core cooled and the shield fell and the air bled away into space, one molecule at a time, over hundreds of millions of years, so slowly that nothing living there, if anything was living there, would have noticed the ending arrive. That tube is a photograph from the attic, a picture of someone we never met, taken by a camera that stopped working an eternity ago, waiting in the cold for us to come and finally look at it properly. And we have spent tonight learning that Mars is not alone, that the sky may be full of tubes like that one, full of dead worlds with the lights still on and nobody home, full of libraries gone dark, full of letters from senders who are no longer there, and that even the worlds still alive, if there are any, are mostly sealed away from us forever, by distance, by time, by the shape of a universe that is quietly carrying them out of reach. And that could be a bleak place to end, but it is not the place we are ending, because there is one more thing to hold, and it is the thing I most want to leave you with. Mars's porch light is still on, in the sense that the sun still rises on its empty rooms. Venus's porch light is still on, behind its burning clouds, over a house that burned down long ago. Around a star like TRAPPIST-1, the porch light flickers and surges and blinds and goes dark 6 times a day. All across the sky, the porch lights are on, and behind almost every one of them, the house is empty, or the house is gone, or the house is so far away and so long ago that the light we are seeing is all that is left of it. But there is one porch light, out of all of them, with someone actually home. One lit window with warmth behind the glass, and a voice in the next room, and the sound of a living world going on around it. And it is not out there among the stars. You do not have to reach for it across 70,000 years, or chase it faster than light, or wait for a tube to come home to be sure. It is the one you are sitting inside of, right now, tonight. It is the ground under your feet. It is the only living world we are certain of, and the only one we are guaranteed to be able to reach, for the simple and enormous reason that we are already here. So here is what I would ask of you, and it is a small thing, and it is the only thing. Sometime soon, when the night is dark and clear, and you can get away from the lights of the town, go outside and look up. Find the small reddish light of Mars if it is up, and know that a rock is sitting there in the cold, holding a secret we cannot yet reach. Find the faint smudge of Andromeda if you can, that little grey thumbprint of light, the farthest thing your eyes will ever catch, and know that its light left before there were any human beings anywhere, and that it is finishing a 2.5 million year journey right there on you tonight. And then look at everything else, all of it, the whole crowded, silent, ancient sky, and understand what you are actually seeing. Not an empty backdrop, not a city of neighbours waiting to be met. An archive, a library with the lights off and the shelves still full. A mailbox with letters from 1 trillion senders of every age, most of them gone, a few of them maybe still there, all of them arriving tonight, on you, still legible, still yours to read, for now, in this narrow early window that will not stay open forever. You do not have to do anything with that. You do not have to feel awe, or grief, or anything in particular. You can just notice it. The window is open. You are in the room. The letters are still arriving. The porch light here is still on, and behind it, the house is still warm, and someone is still home, and that someone is you. The sky is full of worlds we will never reach, and worlds that went quiet before we were born. And that is all right, because they were never really ours to keep, and the looking is the gift, and the looking is still ours tonight. And of all the worlds in all the dark, the last living one we can be sure of reaching is not out there at the edge of everything. It is the one you woke up on this morning. That is more than enough. That is, when you really sit with it, very nearly everything. If any of this stayed with you, sit with it a little longer before you sleep, and let it be, of all things, a comfort. There is still more out there to wonder about, and we will go wandering another night. For now, the sky is up there, and the light is warm, and you are early, and you are home. Thank you for staying with me all the way to the end of this one. Sleep well,